So good afternoon, guys. Thanks for taking a little time out of your day and choosing to spend it with me talking about math. We are going to be talking today about how do I evaluate a function and what does that mean. Just as a reminder, when you hear me use the word function, functions are just math machines. They are things that let us put in an input and get out one output. So they could be equations, they could be graphs, they could be list of points, different things. But the one thing that makes something a function is if I plug in, like say I plug in the number 3 into an equation. If that equation is a function, then I won't have to wonder what my output's going to be. Okay, I'm not going to get different outputs, different times when I plug in the number 3. I'm always going to get the same answer when I plug in the number 3. Something that's sort of new today, you've seen it before but it's been a long time, is function notation. And function notation just means that we name the function. Here's what I mean by that. You're used to seeing equations probably written like this, where it says something like y equals 3x plus 4. Well, let's say that, calling something y doesn't really tell me anything about it. Let's say instead, I write something like this. What I've decided to do here is I've decided to call this function f. Okay, I could have picked any letter that I wanted to, but for some reason on this one I picked the letter F. F stands for my output. So it stands for my final answer. X is my input. Okay? Same thing on this second example. I decided to call this function h. A lot of the time, h stands for height. So what that would mean is whatever I get as my final answer, my output, that's going to be a height. But the numbers that I plug in for t represent time. So for example, let's say that you're shooting a basketball and you film it, and you wanted to know how high the ball was after 2 seconds. T is your input, so you would plug 2 into that equation. Whatever you got as your final answer in your calculator when you plug 2 into that equation would be height. It would be your output. Okay? So for example here it says evaluate the following. The first thing that I'm asked to evaluate is h of -1. Well, I have 3 functions listed at the top up here, so I'm going to go find function h. What do I do with it now? Well, -1 is my input because it's in parentheses. So what they want me to do is take -1 and plug it in for t. And at this point, you have a choice. You can type that straight in your calculator as long as you use parentheses. So notice I put parentheses every time I wrote a -1. Okay? Or you can do this in your head if you want to. I'm going to show you how to do it in your head. You don't have to do it this way. So the first thing I would do is I would say deal with exponents first. So what is -1 squared? Well, that's +1. Okay? Then I would take care of my multiplication. -8 times 1 is -8, and 5 times -1 is -5. Lastly, I would say what's -8 plus -5? That's -13. And then you're done. Okay? So -13 is my output, -1 was my input. The second example says find f of 6. So this time, I'm going to go find function f, which is right here, and this time 6 is my input. So I'm replacing x with 6. And again, can type that straight in my calculator. If I want to do it in my head, the first thing I do is 2 times 6, which is 12, and then 12 minus 5, which is 7, and then you're done. Okay? Very last example here says find g of 7. So here's function g. And notice here it's got those absolute value bars around it. We're not going to deal with those just yet. For right now, we're just going to write them down and plug in our 7. Let's deal with the numbers first, and then we'll go back and talk about what those bars mean. So -3 times 7 is -21. And -21 plus 6 is -15. So what I end up with is a -15 inside those bars. Well, what do those bars do? They make things positive. So if I ended up with the absolute value of -15, what I actually have is just the number 15. You have to remember to make that positive at the end. Otherwise, it is wrong. Okay? All right, next example here. We have a graph this time, and it says find the following. It says find f of 1. So again, what that means is that 1 is our input. Well, on a graph, all of our input values are our x values. So what they're saying is go find where x is 1. So here's 1 on the x-axis right here. What I want to know is what is my output. So where is this red line actually located when x is 1? Well, it's located up here, at 3. So my output is 3. What about f of 0? Well, what they're saying is my input or my x value is 0. Here's 0 on the x-axis. Where is this line, or where is my actual output when x is 0? Well, it's right up here. It's at 5. And finally, what about when x is 2.5? So here's right here where x is 2.5. And I want you to notice something. The line is actually hitting where x is 2.5. Well, what does that tell me? That tells me I didn't have to go up or down at all. My output is just 0. Okay? So what you're doing, the number in parentheses is your x value. You're going to find where the line is actually located at that x value. All right, very last example, just so you've seen this. How does this work in the real world? So below we have a square root function, and we know that because there's a square root in the equation. It says the function below models the speed of sound, and we use the letter F to stand for that, in dry air at T degrees Celsius. If it is 30 degrees Celsius outside and not raining, how fast will the sound of your voice travel? So here's my output. My output is F. Okay? And they told me that my output is the speed of sound. That's what F stands for. My input is T, and T stands for degrees Celsius. And here's the question. If it is 30 degrees Celsius outside and not raining, how fast will the sound of your voice travel? So what would I be asked to do there? Well, I would have to take 30 and plug it in for T, okay? Because 30 in this case would be my input. Whatever I got as my answer would be my output. That would be my speed of sound. So that's just an example of where this applies in the real world. And that is the end of our discussion today.